Hello everyone. Today we are going to solve the problem smallest string we swapped. Given a string S and an array of pairs, each pair have two indices that you can swap the character. You can swap at any pair of indices and any number of times and return the smallest string S. Let's look at the first example. Given a string D, C, A, B and two pairs 0, 3 and 1, 2. First, we can swap index 0 with index 3, so the string becomes B, C, A, D. And then we swap index 1 with index 2, so the final answer is B, A, C, D. Let's look at another example. Given a string S equal to C, B, A, and two pairs 0, 1 and 1, 2. First, we can swap index 0 and index 1. The string becomes BCA. And then swap index 1 and index 2. The string becomes BAC. And then swap index 0 and 1 again. And the final answer is string ABC. Now we understand the problem, how can we solve it? First, we need to notice that if there's a two pairs, 0, 1 and 1, 2, actually there is another hidden pairs 0 and 2. Just like our last example. By swapping 3 times to get a final answer ABC is actually equivalent to only swap index 0 and index 2. In fact, we can rearrange the order of character in index 0, 1 and 2 to any order. In addition, if some pairs are connected, by connected I mean if they share one same index, then we can consider them as in one group. Characters inside the same group can be rearranged to any order. For example, given a string Samoyed, the index is from 0 to 6, and then we're given some pairs. For example, 0, 3, 3, 4, 1, 2, 2, 5, 2, 6, and 5, 6. We can see that 0, 3, and 3, 4, they share the same index 3, and 1, 2, 2, 5, 2, 6, and 5, 6, they share at least one same index. Therefore, we can say index 0, 3, and 4, they're in the same group, and index 1, 2, 5, and 6, they're in another group. Now, in order to get the smallest string out of Samoyed, we need to rearrange the character in first group and second group. The first group consists of character of S, O, and Y, and the second group consists of character of A, M, E, D. After sorting the character in first group, it becomes O, S, Y. And after sorting the character in the second group, it becomes A, D, E, M. Now let's put back those group of characters back to those group of index. The first group have index 0, 3, and 4. So we put character O to index 0, S to index 3, Y to index 4. And the second group have index of 1, 2, 5, and 6. So we put A to index 1, D to index 2, E to index 5, and M to index 6. Last and final answer we can get. To solve this problem, we can divide this problem into two steps. First, group all the connected indexes. Then, sort the characters in the same group. Now, how can we group the connected indices? One way is to consider this index as node in a graph, and each pair between two nodes forms an edge. Let's use the same example. We have a string Samoyed. The first pair is 0 and 3. So we connect 0 and 3. The second pair is 3 and 4. So we connect 3 and 4. And the third pair is 1 and 2. And then 2 and 5. 2 and 6. 6 and 5. By just looking at this graph, we can see that index 0, 3, and 4 is in the same group. Index 1, 2, 5, 6 is in the other group. But how can we find out the group using algorithm? One of the easiest way is using deep first search. Now let's do a deep first search in a random node. First, we have an index array to save the index in the same group, and a character array to save the character in the same group, and a set of scene indicate that we already within a node. Let's start with number 2. So we put index 2 into the index array, and the character in index 2 is M, and we put 2 into the same set. And then it can go to 5, so we put 5 here, and put E here, put 5 here, and then 5, potentially it can go back to number 2, and then because we already see number 2 here, so you go back to 5, and then find another path, go to 6. So we have 6 here, D here, 6 here, same thing, 6 will go to number 2, and find out now we already visited, so you go back to 6, and then go back to 5, and then go to the last level to go to 2, and then 2 have another path go to 1. So last we have 1 here. 1 doesn't have any path left, so we stop here. So we have A here and 1 here. Now we have character in the same group and the index in the same group. We can simply just sort the character and put character back to the index from left to right. Now let's do the same thing to the other group. Let's pick a random node, let's say 0. So we put 0 here, put S here, we already seen 0. And then it go to 3, we put 3 here, we already seen 3. The character in index 3 is O. And then after 3, we can go to 4. And then we seen 4, then put Y here. So now we have all character in this group and all index in this group. We can just sort the character and put the character back to this index from left to right. Let's jump to the code. First, we need to build a graph. I'm going to use a adjacent list to represent the graph. The size of this adjacent list will be the same size as input string. Then we can put each pair into this graph. Now we need to group the indexes. First, we need to have a set of visits. Then, for every index, if it is not visits, we need to perform default search. As we mentioned before, each default search we need to have an index array and characters array. After we perform default search, we need to sort these two arrays. Then we can put these characters back into the string. And we can return input string. There's one more thing left. We need to write the default search function. This function will take input string as argument also the current index, and the index array, characters array, and the set of visits node. First, we need to put the index and the character into the array. Then we need to mark as visit. Then for each index that connects to the current index, if it is not visit, we need to perform default search. Then we just need to put the argument back to this function call. Okay, let's run the code. Okay, seems like it's working. Thank you for watching. I'll see you next time.